Okay, students, let me get situated here as we begin this math lesson. Whoop, there we go. We're going to be using a calculator. But anyways, all right, so let's just dive in. If sine x is 9/41, what is cosine x and tangent x? All right, so this is the same things we were doing above. This is just going to be a little bit more advanced. All right, so let's investigate this. We have sine of angle x. Now remember, sine of x is opposite over hypotenuse. And in this case right here, it said it was 9/41. So with respect to angle x, the opposite side would be this. So this side right here is 9, and then the hypotenuse is always the hypotenuse. This is 41. All right, we need cosine and tangent. Now both of those signs incorporate the adjacent side. We don't know the adjacent side. So what we're going to have to do is use Pythagorean theorem to find it. So I'm going to call the adjacent side A. Wow. All right. So anyways, all we got to do is do, oops, my calculator is going to be a problem. We'll save that for later. A squared plus 9 squared equals 41 squared. Now, I have this memorized. I know A is 40. It's a Pythagorean triple, but let's actually do the calculations. A squared plus 81. 41 squared is 1681. Subtract 81 from both sides. And A squared equals 1600. Take the square root of both sides, and A equals 40. All right, so this is kind of cool. We were given just the sine ratio, the opposite over hypotenuse, but using Pythagorean theorem, we were able to find the adjacent side. Now we know all three sides. Now I can write cosine and tangent. All right, let's see where I'll do it over here. Cosine of x, remember, is just adjacent over hypotenuse. Adjacent side is 40, hypotenuse is 41. So that's it, it's 40/41. And realize, like in the future, you're just going to be writing cosine x equals 40/41. You don't have to write adjacent over hypotenuse each and every time, but this is something new. So we're just building that repetition. And then tangent of x, again, you don't have to write this in the future, but we are right now, is opposite over adjacent, which is going to be 9/40. All right, so those are my answers. Given one trig ratio, we're actually able to figure out all three trig ratios due to Pythagorean theorem. I find that pretty cool. All right, nonetheless, here I gotta minimize that. That's for next problem. All right, same thing. Write tan, or if tan of x is 13/12, write sine and cosine ratios. All right, so what I would do here is draw the right triangle. All right, you don't technically you can do this without drawing a right triangle, but it's just a good habit. We're given tangent, which remember tangent we just wrote is opposite over adjacent. So with respects to angle x, the opposite side is 13. The adjacent side is 12. So now we got to use Pythagorean theorem to find the hypotenuse, which we'll call c. So 12 squared plus 13 squared equals c squared. We get 144 plus 169 equals c squared. Now what is 144 plus 169? 313. So we're going to get some decimal. That's okay though. We have to be comfortable using decimals. The square root, the square root. So c, the hypotenuse, is going to equal the square root, the square root of 313, which is 17.7, round to the nearest tenth. All right, so then writing those ratios, cosine of x is adjacent over hypotenuse which is going to give me 12 over 17.7. And then tangent, sine, is going to be opposite over hypotenuse, so 13 over 17.7. Cool beans. All right. Now, a 13-foot ladder is leaning against a brick wall and 12 feet high. All right, I forgot to incorporate this in. It's a 13-foot ladder. It's leaning against a brick wall. All right, what is the angle formed by the ladder and the wall? What is the cosine of the angle? So this is what we want to do. We got some pink ladder. Cool. This ladder's 13 feet high. It's leaning against a green wall, 12 feet high. All right, and then we'll have the floor like that. So analyzing this, we got this right triangle here. Oops. And then I want theta. We haven't used theta in a while. Theta. We want that angle right there. So cosine of theta is just adjacent 12 over hypotenuse 13. And that's all you'd have to do for this problem. All right, so why is this important? Why are we doing this? Who cares? I think I've already said this, but trig is so great. It helps us find unknown lengths when we know an angle measure of one side and the length of a right angle, or right triangle. We use it in construction, architect, astronomy, engineering. Here's just a picture, like here's the Earth in June, a nearby star, there's some angle, there's a right triangle. Then in December, boom, we can just use math, trigonometry, all this stuff to find distances of stars and just know how the universe works and all that stuff. But before we start doing some calculations, so some unbelievably cool math problems, if you want to be cooler here at Hilliard-Darby High School, you must get good at trig. Let us first understand how to use a calculator and some other basic facts. All right, so let me see. Hopefully my calculator actually works this time. What the heck is going here? There we go. All right, so look, like all I'm going to do is cosine. See, it's right in the middle of the screen. I'm going to type in cosine 32 and hit enter. All right. In fact, what I need to make sure first is my mode is in degrees. So
how to make an ice cream cake at home. Create a layer of ice cream sandwiches. Next, cover the sandwiches with a layer of wood.
She shows me TikToks every night. Anyways, so let's clear. So cosine of 32, cosine of angle 32, boom, it's just some number. All right, it's a really ugly decimal, but realize it's just 0.848048, and I could keep on going. All right, so realize that's just some number. Some number, not some hashtag, some number. Well, let's do sine of 72, enter, 0.951. And also when we do these videos, you have to know how to use a calculator. I wouldn't rely on just watching me do it, because this is a little new. Understand how to plug it in, make sure your mode's in degrees, not radians and all that stuff. But realize that all this stuff is just some number. Tan 82, enter. So it looks scary. Don't be too scared. Dot, dot, dot. Like radian, degrees, make sure you're in degrees, because that's what we're dealing with. All right. But although these trig functions are brand new, realize they are relationships of acute angle measures and ratios of specific side lengths. In other words, trig functions in this case are just numbers. Don't be too scared, dot, dot, dot yet. All right, in this next video, we're going to solve some problems.